Hi everyone, welcome back. In this video, we will see the resolving the forces example number 5. Check the link in the description for the basics of resolving the forces and resultant force calculation and other examples. Two identical spheres of each weight 2.5 kN rest in between an inclined wall and a vertical wall as shown in figure. Determine the reactions at the point of contact P, Q and R. Assume the wall surface to be smooth. Now let's draw the free body diagram for the sphere 1. So the self weight which is acting in the downwards direction, which is 2.5 kN, and we have one reaction force at the point P, and we have one support reaction at S. This support reaction is parallel to the inclined surface, so opposite angles are equal, so this angle is 30 degree, and here this angle is 30 degree, so if you subtract this 30 degree from this right angle 90 degree, we get this angle as 60 degree. Now let's draw the free body diagram for sphere 2. If we draw the free body diagram for sphere 2, the self weight of the sphere which acts in downwards direction, which is 2.5 kN, and we have one support reaction at Q which is acting at an angle of 60 degree, and one reaction force at the point R and one support reaction at the point S. Now we have to resolve the forces to find the values of P, Q and R. First let's resolve for sphere 1. If we resolve, just I took this 2.5 kN to here for clear understanding. Now we resolve this P into minus P cos 60 degree and plus P sin 60 degree, and we resolved this S into S cos 30 degree and S sin 30 degree. Now resolve all the forces in sphere 2. If we resolve this, we get R 2.5 kN, and if we resolve this Q, we can get Q sin 60 and minus Q cos 60. For S, we get minus S cos 30 and minus S sin 30. Now we have to resolve all the horizontal components in sphere 1, which is equal to 0. If we take all the horizontal components, S cos 30 minus P cos 60, which is equal to 0. And by solving this, we get one equation, S is equal to 0.577p. We can take this as equation 1. Now let's resolve the vertical forces in sphere 1. S sin 30 plus P sin 60 minus 2.5 is equal to 0. Now substitute the value of S from the equation 1. So in this value place of S, we can substitute 0.557p, and here the only unknown is P. If we solve this, we will get the value of P, which is 2.166 kN, and substitute this value of P in equation 1. S is equal to 0.557 into 2.166. We get the value of S, which is equal to 1.25 kN. Now we have to follow the same procedure for sphere 2. In sphere 2, we have to resolve all the horizontal components. R minus Q cos 60 minus S cos 30 is equal to 0. Keep this R in left side, and we can take this two variables to the right side. We get one equation. Now resolve all the vertical components in sphere 2. Q sin 60 minus S sin 30 minus 2.5, which is equal to 0. Now in this equation, Q is the only unknown, and we can find the value of Q by solving this. Substitute this Q value in the equation 3, we get the value of R. R is equal to 2.88 kN. Now draw the result drawing, which is P is equal to 2.1 166 kilonewton, Q is equal to 3.161 kilonewton, and R is 2.888 kilonewton.